All right, we're back. We're going to start with composition of functions. Pablo has a question. Yes, Pablo. Okay, so let's get started. So we're going to focus just on this part of class on function operations. That's adding, subtracting, multiplying, dividing with functions. All right, and then we're going to move into function composition. All right, it's going to be a little bit confusing, but hopefully after a little refresher, you feel confident about this moving forward. So let's start by talking about function operations. How would you read this, Jimena? How would you read this? Give it a shot, right? Perfect. Stop. Done. That's it. G minus f of x is exactly right. Does anyone know another way that you could write what it's asking you to do when it says g minus f of x? Giuseppe. Perfect. Giuseppe is exactly right. G of x minus f of x. So it wants us to take the function g of x and the function f of x and subtract them. All right, so I'm going to write down g of x, which is x squared minus 1, minus f of x, which is x minus 1. What do I always do with the second function after subtraction? I always put it in parentheses. If you don't, you're going to probably end up messing up the subtraction of your second term. Okay, now, at this point, some teachers might ask you to distribute the subtraction, that negative sign, onto each, then it becomes addition, or you can do what I do, which is just subtract it. All right, x squared has no other like term. See how it's the only x squared? So in my answer will be x squared. The next thing I should write about is the x term, if we're doing it in standard form, this x term. So think about it, this is hard here. Listen. There's no x term, so 0x minus x. What is 0x minus x? It is negative x. 0x minus x is negative x. Right? Or ox minus x is negative x. Yes? Now we're on to the constants. What is negative 1 minus negative 1? No, it's nothing. Negative 1 minus negative 1, they're the same. When you subtract them, you get nothing. All right, so we are done. That's the answer. This is the function g minus f of x. So this right here is down here. G minus f of x. What's up, Giuseppe? Yes, that's the answer.
So just solve until they're on the variable.
We didn't say solve, right? We're not solving here. We're just finding a new function. All right, we're adding, subtracting, multiplying, or dividing. We're not solving anything. I could ask you to evaluate this. All right, this is a fun thing that some of you may have done or may have not done. Listen up here. All right, what if this had said g minus f of 3? Then what would I be putting into my x? I'd be putting 3, so it would be 9 minus 3, which is 6. All right, that's called evaluating. That would be evaluating one of these functions. Yeah. Yes, Pablo.
Where do you get the 1 from?
Where do I get the 1s from?
Oh, okay.
Basically, the way I think of this, Pablo, is when you were in middle school, you learned about adding and subtracting like terms, right? Or adding and subtracting polynomials.
Yeah.
Now they're taking that and calling it fancy by adding function notation. All right, so this is just glorified, you know, like how people go glamping, like glamorous camping, like that's a thing, like people do that, as opposed to like going into the woods, sleeping under the stars, in a tent, like in a sleeping bag, right? People actually go and like sleep in beds out in the woods, which it makes no sense to me, because like you have a bed in your house. Anyway, this is all this is. It's just glorified adding and subtracting polynomials. That's all this is. All right? They're making it sound like it's more lavish than it really is. Okay? All right. Let's go to the next one. How would you read this one, Heidi? How would you read this one? Perfect. G over f of x. Now, Giuseppe's not going to answer this one. Well, what's another way you could write G over f of x? What's another way you could write that? Yes, Gilberto? Perfect. G of x over f of x. All right, so they're asking us to use what operation here? Division. All right, so let's do division. I'm going to write down G of x, x squared minus 1, over f of x, which is x minus 1. What do we do now? Can't cancel out anything here, because you have to do something before you start crossing stuff out. What's that called? What is it, Bashir? It's factoring. Oh, Heidi, it hurts me. Really, really, that's a lot. Hurts a lot. Hey, factoring. Oh my gosh. Factoring is the best. So, does anyone know the name for x squared minus 1? It's a special case. What would you call x squared minus 1? It's a quadratic, but what would you call this special case x squared minus 1? Oh, this would be amazing if you remembered this.
Can you give us a friend there?
I'll give you this. Dots. Nope, it's not foil. Dots. The difference of two squares. The difference of two squares. All right, it's been a while, I guess, so let's factor. What is the square root of x squared? What's the square root of x squared? Just x. So I have x and x. What's the square root of 1? Don't think so hard. It's just 1. 1 positive, 1 negative. That's called the difference of two squares. That's how it factors. So if you were to multiply this out, you would get x squared minus 1. You want to do it mentally real quick? Yeah, okay. What's x times x? X squared. What's x times negative 1? Negative x. What's x times 1? 1x. When you add those together, they become 0. And what's 1 times negative 1? Negative 1. That's the difference of two squares. Pablo. What if it was x cubed minus 1? That's called the difference of two cubes. That factors differently, but it's still a special case. All right? Difference of two cubes. Dot C. Okay. Yes.
So one has to be positive and the other one negative, no.
In the factors? Yes, always. Here, this has to be subtraction. It's not the sum of two squares. That's not a thing. SOTS is not a thing. The sum of two squares is not a thing. Only the difference of two squares. Now, the cubes you're talking about, Pablo, the sum and difference of two cubes is a thing. Only when it's squared and it's subtraction. And then, Pablo, these need to be both perfect squares. Like if this was x squared minus 6, that's not helpful because 6 is not a perfect square. But if it was x squared minus 9, 9 is a perfect square. Now, Diana, what do you notice when I bring down the denominator? You can cross out and make 1. These will make 1. And so I'm left with x plus 1. Now, it's not just this, though. There's something else I have to put for this to be finished. There's something else I need to put. I'm sorry? No, not plus or minus. I didn't take the square root of anything, but I like where your head's at. Giuseppe, do you remember? Oh, you want to put the actual... We can do that. Like, make it fancy. All right, there it is, official. But there's something else. Something else I need to put because of what we had going on here. When I look at this, alarm bells go off in my head.
Would you put comma, x squared?
Comma, what?
X squared?
No, it's comma something. There's something I have to mention based on what I wrote here. And I want you to look in the denominator.
Oh, x minus 1.
X can never be what number? Positive 1. Because if x is positive 1, I have 1 minus 1, which is 0. And can I ever have 0 in the denominator? No. So you need to write comma, x cannot be equal to positive 1. All of this would be what I would consider the answer. Yeah, good times. Why can't it be 1? Pablo's asking, why can't it be 1? Because what would happen if I plugged in 1? It would make 0 in the denominator. Now, here's what most people think, Pablo. They say, well, if you plug in 1, you get 1 plus 1 is 2. But you have to go back before you cross things out. And 1 would make this denominator 0. And we cannot divide by 0. 1 would actually make the numerator 0 as well. You see that?
You're putting this on test?
Putting this on a test? Yes, I'm putting this on a test. It's going to be okay. Questions? Can we move to composition now? That's called function operations. You'll notice I only did 2 operations, subtraction and division. What are the other 2 that I did not cover? Multiplication and addition. So make sure you know how to do those. Okay. Let's talk about composition. There's a couple of ways you can write this. Whenever I mention this to students, they always joke that it's the fog of x, but it's not. It means f of g of x. So you'll see most teachers will just use this notation right here, f of g of x. All right, that way students don't say fog. All right, so let's try one. F of g of x. Now, I've decided after doing this for 8 years that this is the best way to go about trying this if you're still having trouble. So the first thing I ask is, what is the first letter you read? F. What is the f of x function? Very good. So I'm going to write down 2x plus 1, but instead of an x, I'm going to put a big giant box. Not the problem. Then I'm going to put the other function, this inside function, which is g of x. So I'm going to take 3 minus x and put it in the box. In parentheses. And what I'm hoping that you see is that you should still see 2x plus 1, but what has replaced the x? The other function. All right? That's what I tried to do the last couple of years, and I've had more success with students. So I'm hoping that this will give you success as well. All right? Then it just becomes some algebra of distribution. 2 times 3, 6. 2 times negative x, negative 2x. Bring down the plus 1. Clean it up. Negative 2x plus 7. Good? Questions? Yeah, Pablo.
So on that x inside of the little, the 3 minus x, that x you don't have to make it to 3 minus x.
That would be f of g of x of g of x. That'd be a composition within a composition. That's like the movie Inception. We don't do that. All right? Have you seen that movie?
No.
You should watch it. Be careful. It's dreams within dreams within dreams within another dream. They like go into people's dreams and like change the way they think about something.
Yeah.
They can manipulate people by their dreams. It's crazy. Inception. No one's ever seen that movie? My goodness. Leonardo DiCaprio. What's that one woman's name? There's a French actress who was like one of her first American movies. Now she's like super famous, but I can't think of her name. That's not who I'm thinking of, but he is in it. Marion Cotillard. Her name is Marion Cotillard, but she's French. Says Marion Cotillard. She's really good. She's a good actress. Okay, let's go to the next one. Ellen Page is also in it. Nope. Man, you guys don't know any actors' names. You'll get there. You'll learn this useless knowledge when you get to college. Okay, G of f of x. What's the first letter? What's the first letter? G. So I'm going to write down 3 minus, but I'm not going to write x. I'm going to write a big box. And in that box, I put in parentheses 2x plus 1. I'm going too fast? Okay. I'll pause. Are we good? Now I'm going to distribute the negative So I have negative 2x minus 1. So the answer is negative 2x plus 2. So that's g of f of x. And we're finished.
Why is it a negative?
Why is it a negative? Because I take this subtraction, and it's a negative 1, and distribute it onto both terms that are in the parentheses. So it becomes negative 2x and negative 1.
Why is it
Any questions on composition? So we have just over 10 minutes, really about 10 minutes, so we can move the desk back. Giuseppe? We have just about 10 minutes. I want you guys to work on these problems, the at your board problems right here. Right here. Work on these 4. All right, I mean it's 2, but they're doing 2 each, so 4. And then I'll tell you when to stop if you're not done, to erase everything, put everything back, and move the desks. All right? Go! Not right now, no.